All right, so graph the inequality. So we have number 8, y is greater than x squared minus 9. So remember, because these are inequalities, we have to pay attention if it's going to be solid or dotted. So is this one going to be solid or dotted? Dotted. So I'm just going to go ahead and note that because it's not something you necessarily think about when you're graphing parabolas, that, oh, it's an inequality. All right. Do you remember how to graph a parabola?
You have to find the axis of symmetry and the vertex.
Okay. How do we find the vertex?
Well,
Or do you remember what the x coordinate is?
It kind of
B
helps.
over 2a.
Yep, negative b over 2a. So there's no b term here. So what does that mean our x coordinate's going to be? 0. So our vertex is going to be at 0. And when we plug it in, so x equals 0, that means that that goes away. So we're left with negative 9. And you don't need to actually necessarily graph the axis of symmetry. Like, you don't necessarily need to show it like we did before unless you just really want to. I'm okay with you not graphing it with these ones. But we're going to set up the graph. So, this one has to go way down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So at 0, negative 9 is our vertex point. What other value for x do you want to plug into?
1.
1. All right, so 1 minus 9 is negative 8. So on both sides, obviously we still have the axis of symmetry here. So what we do to one side, we do to the other. And then it's dotted. So we just have to connect. All right, and then y is greater than, so where are we shading?
Inside.
Yep, inside.
So why was the x value 0 for like when we're doing the vertex?
So because it's minus b over 2a, we don't actually have the b term. The b term is the one that's just the x value. Since this one didn't have anything but the x squared and the constant term, it was 0.
Okay.
But if it had a b, we would have plugged it in and then gone from there. Yeah, they're just starting off easy. There we go. All right, let's see, number 10. Y is less than x squared plus 4x minus 5. So is this one going to be solid or dotted? Dotted. All right, so to find the vertex, we're going to do, this time we will have something. So the minus b over 2a is equal to negative 4 over 2 times 1. So that's just going to be negative 2. So the vertex, the x coordinate is negative 2. We plug that back in, so we have negative 2 squared plus 4 times negative 2 minus 5. So that's 4 minus 8 minus 5. So is that negative 9? It's like the 9s today. So it's at negative 2, negative 9. So at negative 2, negative 9. I would say since 0 is only 2 away, I'm going to plug in 0 because that'll be the easiest thing to plug in. So at 0, we're at -5. So 2, 3. And then remember that was 2 away, so we need to go 2 away in the other direction. It's dotted. And its y is less than, so where would we be shading?
Outside.
Yep, outside.
So how did we get the other 2 points?
These ones?
Yes.
So I just plugged in another random number on either side, so my axis of symmetry is, whoops, well, anyways, you get the idea. The axis of symmetry is there. So I'm looking for a point on either side of it that I can test, and I can test any point, but I will always try to test 0 if it's an option, and it's not too far away because it's obviously the easiest mathematically to do. But I'll usually try to go no more than 1 or 2 away either, because at that point it can make your graph go like really, really big. Yeah. And like you just don't need to do that, but there's nothing wrong with it. It just, and then whatever we did to one side, we just copy it on the other side.
Cool. So you just plug that back in?
Yeah.
Okay.
So just whatever number you pick, you're just plugging it into the original, and then you're just getting the y value for it. All right, so I'm going to do one more that's just the single one, and I'm going to tell you the numbers are not pretty. It's just the nature of it, but it's something about it that I want us to see, which is why. And then we're going to do one that you graph 2 on the same and find the intersection of the 2. So 12, we have y is less than or equal to -x squared plus 3x plus 10. So what do you notice about this one in particular?
Less than or equal to, and
So
the
it's-
negative.
Yep, so less than or equal to, which means it's going to be what? Solid. And then the negative means it's going to be what?
Flipped.
Okay, yeah, it's going to be reflected, so it's going to be upside down. So instead of them being up, it's going to be facing down this time. So find the vertex same way. So minus b over 2a. So -3 over 2 times. Now there's an a value, and we do put the sign with it. So 2 times -1. So that is, the negatives cancel, so that's 3 over 2. If you want to treat it as 1.5 just to make it easier for the sake of graphing, that's completely fine. A lot of times when I have something like that, I'll actually write the vertex in a fraction form and in a decimal form, just so that I can see it. You'll have your calculator, so like when you go to plug the number in, if you want to just plug it in as a decimal, that's fine. I didn't let you have your calculator when we were graphing parabolas before because I didn't want you to be able to just graph them on your calculator, so. But at this point, you have to still know how to shade it, and if it's solid or dotted, so it's not going to help you too much. But anyway, so we're going to plug 3 halves or 1.5 in for x. I'm probably going to plug in 1.5 and then just type it in the calculator. But so -1.5 squared. Now notice the negative is not getting squared, so that's why I've written it like this. It's just the 1.5 that gets squared, plus 3 times 1.5 plus 10. And I'll just type that in really quick. So 1.5 squared, it's negative, plus
2.25 plus 4.5 plus 10.
that's not that. So it's 12.25. And if you're just so inclined to want it as a decimal, or I mean as a fraction, it's 49 over 4. So a lot of times when I'm graphing, I do prefer to have decimals just because they're easier to work with. So let's see. Let me move this down. All right, so at 1.5 and 12.25 is our vertex. So my 0 is only 1.5 away, so I'm going to test that point. So I plug in 0 to the original, so everything goes away except for the 10. So at 0, 10, I have a point. That's 1.5 away from my axis of symmetry. Actually, this dot needs to get moved. 1 second. So 1.5 away on the other side puts me at 310. Now it's solid, so I just get to connect it like normal. So now y is less than or equal to, okay, but notice it's upside down, so where would I be shading? Because it doesn't exactly follow the notes because it's reflected inside. So when they're reflected, it's different because you're still looking for where the y values themselves are less than or greater than, and the y values are less than in this one inside of it. So the little chart that we wrote yesterday only works if they're right side up. All right, so the last one that we're going to do is one where we're graphing two of them together. So I'm going to write them side by side so I can work the math stuff that goes with them underneath. So y is greater than or equal to x squared minus 4, and then the other one is y is less than or equal to negative 2x squared plus 7x plus 4. And sometimes when you do these, you'll have one that's solid, one that's dotted, and, you know, whatever, so. But they pretty much all are always going to have, I would say, in most cases, they're going to be going opposite. So, both of these are or equal to, so they're both going to be solid. The second one has a negative, so it's reflected, so I know it's going to be upside down. So what would my vertex be for the first one?
The x value is 0.
The x value is 0, and then if you plug in 0 for x, what are you left with?
Negative
4.
-4.
So it's at 0, negative 4. And then for the other one, this is going to take a little bit of work, so what would my x coordinate be?
7 over 4.
7 over 4, because it would be negative 7 over negative 4, which cancels, so 7 over 4. Let's do this so you can see it. That's where that came from. And then we plug that in. Again, if you want to use a decimal, you can. So it's negative 2 times, I'm going to tell you what the decimal is, 1.75 squared. And notice only the 1.75 gets squared, not the -2 that's with it, just the x value. Plus 7 times 1.75 plus 4. So this is 10.13 approximately. And that was 1.75 just for reference.
Where did we get the x value for the vertex from?
Minus b over 2a.
Oh, that's right.
Yeah. So then I can set up my graph. So I'm gonna do one of them as blue and one of them as red, just so that I can see where the two different ones are. So do the easy one first. The vertex at 0, -4. Oh, that's the wrong color. Whoa, come back. Okay, 0, -4. So then I would just use something like 1, that's 1 away from it. So if I plug in 1, 1 minus 4 is -3. So at 1, I'm at -3. 1 on the other side at -3. It's solid, so I can just connect like normal. And its y is greater than or equal to, so where would I be shading? Inside. So I'm going to shade this one in light blue. So then the other one, I have a vertex at 1.75 and 10.13, so basically 10. So that's obviously almost 2 away from 0, so I'm going to try 0. So if you plug in 0 up here, that term goes away, and you're left with 4. So at 0, 4, I have a point, and then basically almost 2 away over here. I'm not quite at 4. You have another point. And when they're weird decimals, just get it as close as possible. You don't have to be like, super exact about it. This one's also solid. It was supposed to be reflected, so that's good that it did that. And then this one, oops. I'm going to shade this one in pink to try to. All right, so it's y is less than or equal to, so where is this one getting shaded? Inside. So this area where both colors overlap is the solution to this problem. Any questions about those? All right, so your problems are going to be 7, 13, 15, and 21. If you don't finish them before the bell, you can finish them the first 10 minutes of class on Monday, and then Monday will just be a review of these few sections for a quiz on Tuesday is what we'll do. And then Wednesday we'll start trig.